I just want to look up and it's just moons.
Just moons.
Just moons.
Nothing else.
All the way down.
That's right, folks. We're packing our night sky full of moons. Welcome to Dead Planet Society. I'm Chelsea Whyte.
And I'm Leah Crane, and today we're talking about one of our very favorite celestial objects, moonmoons.
I just love that word. I remember when I first learned it because you wrote this story in 2018 that had my favorite headline of all time. Moons can have moons, and they are called moonmoons.
That story was my magnum opus. Two researchers named Julie Kohlmeyer and Sean Raymond did this study, and they found that it's actually possible for 4 of the different moons in our solar systems to have moonmoons.
Yeah, it's like fractal moons. So a moon orbits a planet, and a moon orbits a moon around that planet.
And a moon orbits a moon, and so on forever and ever. Amen.
So we were wondering, how many could there be? How far could that go? Could we get it down to moons?
But before that, we do need to know how many moons we could pack around Earth. And then we can talk about how many moons we can add, because we really just want the whole package.
Yeah. And the thing is, adding that much stuff into orbit around Earth does seem a little dangerous, right?
Yeah, probably. I mean, if it busts up and rains down, we're totally screwed. But also, if it all smashes and melds together, that's not awesome either.
I mean, I don't know, not great for life, but very cool looking.
Yeah, on the upside, no matter what happens, Earth ends up with rings, which is what I've wanted all along.
Beautiful and terrifying.
Aw, thank you. You too.
Well, we called up Sean Raymond at the University of Bordeaux to ask him to revisit the moonmoons with us and help make them possible.
Before we can have moons, we must have moons. And I'm wondering if you've thought about how many moons Earth could have. Because I just want us to have the maximum possible stuff.
And by maximum possible, do you mean like the most sustainable amount of moons that it doesn't immediately get destroyed?
Yeah, and of a reasonable size. Because I think otherwise that's just rings.
Yeah, you don't want rings. Those are, I mean, they're cool and pretty and all that, but you can't go stand on them.
Yeah, exactly.
So this is a good question. In anticipation of talking to you, this is why, like a couple weeks ago, I was like, I should make sure I think about this before I talk to you two. And then this morning, I was like, oh crap, I haven't done anything. And so just today, I went and did. I was like, I was trying to take, what we kind of figured out for planets around stars and extrapolate it to moons around planets. And in theory, it should be the same thing. And so for like planets around stars, we know kind of how close planets' orbits can get before you squish them too much and then they're not stable anymore. But then you can do other weird tricks like put many planets on a single orbit around a star, that kind of thing.
Yeah.
And so for fun, I tried that with moons around the Earth just this morning. And it's not as stable as I would have liked. I wanted everything to be stable, which is not the case. But I did find some cases that do work.
Okay.
You can't have a ring of moons the size of our moon, but you can have a ring of moons. I think I did a simulation with like 10 moons.
Oh.
That stayed stable for pretty long. Not our moon, but the moons are smaller. They're the size of Ceres.
Is that something that we still see? Would they be at the distance of the moon?
So this was a weird thing that I don't know why, because I haven't figured this out yet. But if I put them at the distance of our moon, they're not stable.
Oh.
Right? And I think it's because the sun basically kicks them at a certain frequency that messes things up. But if I shrink their orbit by a half, so just put them like, half the distance to the Earth, which is perfectly stable.
Yeah.
Then it works.
So then my question is, would they be a similar size in the night sky to the moon? Even though they're smaller, they're much closer.
Yeah, you're right. So they'd be half the distance, but in actual size, they're what? The Ceres is like, 1,000 kilometers across. Our moon is like about three times bigger. So
Okay.
they'd still be a tiny bit smaller.
A little
Tiny bit smaller
but
than the moon
10
sky,
of
but
them.
you get 10 of them. They'd be constantly rotating in and out of view.
That'd be incredible.
It's a trade-off.
You could have a line of moons across the sky, right?
Exactly. It'd be like the Starlink satellites, except with moons.
Yeah.
Better. Would they be in slightly different phases from each other because they would be sort of around the Earth? I'm imagining sort of equidistant spacing around Earth.
Yeah, you're right. They'd have to be about the same spacing. And yeah, you're right. They'd be kind of sampling all phases at any given time.
That'd be really cool.
And maybe you could have every so often when the ring was in the right orientation, you can get eclipses, 10 eclipses a day. That'd be
That would be
Yes.
so cool.
I want that. I want 10 eclipses a day.
Yes.
But then if each of those moons had a little submoon that was big enough, they
Yeah.
could cause little blips on the eclipse. That'd be cool,
Okay,
too.
but could all of those 10 moons have a moon?
I didn't figure that out. I don't know.
It seems like it would probably not be particularly stable.
I think it's iffy because let's see, the moons are more stable for massive moons far from their planets. Our moon is actually quite far, and so moving it half the distance is not so bad. I think it's iffy. I think it's a borderline. It might be possible.
I wonder if you could have just one, but it does an orbit around like a figure 8 through all of the moons.
That would be so
Oh,
cool.
like it
Like
snakes
it's a
Kinda bounce
moon
them.
between
in
them.
its own right. I guess that's not really a moon. That's just another moon.
That would be amazing.
Yeah,
if
but
you
it's
could
the
do that.
wandering moon, and I love it more than all the other ones.
Yeah, that would be really cool. I hope that's possible. I don't know if it's possible.
So then I am curious, though, if we didn't have the smaller moons closer to us, but we had just our moon, if we launched a moon around it, how many moons could our moon have?
Basically, how many
good
satellites
question.
could we put around the moon?
Yeah.
That's a good question. I think you can put plenty. The thing is, like, if you do it in such a way that your own moons have a little bit of control over their movement, then you're good. It's fine.
Right, as long as we put thrusters on them.
Yeah, little bitty thrusters, you're okay. Otherwise, there's these weird kind of mass cons, they call them, like mass concentrations on the moon that can screw things up.
Oh, you mean like a sort of like a lump of mass somewhere on the moon has more pull or whatever, so the orbit of the moon would get messed up.
Yeah, they figured this out, I think, in the 60s and 70s, where basically they're trying to put satellites around the moon. They found these little mass concentrations that mean it's not a pure, simple thing where all the gravity's in one point, basically, or you can't do that. And so then that makes it so the orbits are perturbed by this. It's annoying.
Okay.
So we couldn't have lots of natural moons because the moon's lumpy and it wouldn't work. But,
Exactly. The lumpiness. That's a good way to put it.
yeah, but
Exactly.
if we put just little thrusters on them, we could have natural ones and we just glue a little thruster onto it.
Yeah. And I was looking, while we were doing this paper, I never found this. It must exist, but I never found anyone that kind of scanned all of the possible orbits around the moon to see which ones were still stable. Because I think a lot of them still are. It's just the ones that are most useful for moon landings. Those ones are not.
Yeah, so it doesn't need to be. I was just thinking, like, couldn't you solve it by moving it a little further out, or putting it in sort of like an oblique orbit, something that isn't useful for maybe scanning the topography with an orbiter, but is useful for me to make a moon.
Yeah, exactly. I know it's possible to have. There are weird solutions where it can work, like a very oblique orbit.
Mhm.
And that was the idea of that NASA mission. I'm blanking on the name right now. The one of having the basically a station orbiting around the moon.
Oh, Gateway?
Yeah.
Yeah.
Lunar Gateway. I think that we could just get a cosmic stick blender, just put it inside the moon, just puree the inside so it's nice and smooth.
No, I don't.
That's another option. Yeah.
I
don't
think
see why
that's
we
going to
can't do that.
destroy the moon. That's all you want to do, really.
And
No, I want it to be intact because we could give it like a little plaster cover, smooth out the tops.
but it's in the inside that the
Oh.
mass density is different. So what we need is a stick blender.
I like this idea because that way you can kind of smooth out the moon, but without having it fall onto the Earth. Otherwise, if we smash it to pieces, some of them are going to land on us.
Right.
Yeah.
This way we just put a hole and we stick a stick blender in there. Big one, big expanding one. Just
Liquefy the moon.
liquefy the inside, but we'll leave the shell intact. We'll leave the crust intact, liquefy the mantle. I
And then we
think it'll
just
work.
need
Totally.
one large cork to plug the hole.
big
Yeah.
cork.
Yeah.
Exactly.
But I was thinking, like, in another approach would be to set up our moons around our moon in these oblique orbits. And I'm wondering if we can get a couple of them going in concentric orbits. Not necessarily all in the same orbit, but just sort of like some nested inside of each other. I suppose, like Saturn's rings, but intact.
I think that kind of thing has got to be possible if you arrange it just right. I've never looked for it very carefully, but I imagine it's possible if you do it really carefully.
Just because it's possible, I wonder, do you think there's some place out there, the universe is pretty big, where it exists?
Oh yeah, I mean this is a big thing. On my blog I do a lot of this kind of thing of if something is possible, does that mean it should really exist? And so for things like moons, I think I wouldn't be surprised if they don't even exist in the solar system. I bet they're kind of small and puny and they're hard to find, and maybe they don't last forever because they're so small and they break into pieces. But I bet there's some out there that we could find like now if we looked really carefully.
Okay,
Yeah,
call
well, I
NASA. This is all I want us to do.
I think they've seen in like a binary asteroid where one of them has a moon. That's kind of a moon.
Oh yeah, that's a good point. Yeah, you can call it that.
Kind
Yeah.
of. But if
Why
we're
not?
calling one of the asteroids a moon of the other one, then it's a moon.
Sure. Iapetus. I know like Iapetus around Saturn was a really good target for moons too.
Oh, really?
If we focused our energy there, yeah, that was the one that was very massive and far out. It has that. Iapetus is the one that has this weird ridge along the equator.
I call it the little walnut that could.
Yeah,
It looks like a walnut.
Totally, and some people think it was actually a moon that crashed down.
Yeah, like it got busted up and it made a ring and then fell onto the planet in sort of a stripe all the way around.
Yeah,
Or not
that's
the planet,
like
the moon.
when good moons go bad, it turns into Iapetus.
Yeah, it turns into a ridge. So if we get
Yeah.
enough of them going, maybe in non-planar orbits, we could make a like weird crisscrossy moon
Ooh.
eventually
cool.
when they smash up.
Yeah, they're not going to be permanent.
We could do weird ridges.
This is making me wonder how far we could push it. So I'm wondering if we could give our moon a moon, and the moon a moon, and the moon a moon. Like, how far down the fractal can we go?
This is awesome. So some dude back in like the 70s had actually figured this out already. So his rule of thumb was that to go down one level, you have to go down in mass by about a factor of 100,000.
Oh.
Right? For it to be stable against these tidal effects. And so for a moon, it's got to be something like 100,000 times less massive than the moon.
Okay.
And then in theory, you can just keep going and going. And so if you do the math, the biggest, I think we did the math in the thing, right? I think then when you get to a moon, the biggest one you could have is, like 100 kilometers in size.
Okay.
And then you keep going, and then you're down shrimpier and shrimpier.
Yeah. At what point do we get to a Planck mass?
Exactly.
Or just a pebble. Like, yeah, when does it stop being a moon if it's just dust out there?
Never.
I know.
Yeah.
I know.
But it sounds like maybe you could have like 4.
Yeah.
Yeah, I mean, sure.
Maybe 4, maybe 5, and then it's just...
You can have like stars orbiting other stars. I don't know if that counts though. But say at least planets going around stars, moons going around planets, moons going around moons. You can at least do that.
Yeah, and probably
Can
I
you
think
keep
you
going
could do
from
one
there?
more.
Maybe.
I think you could do
Yeah.
a moon.
I kind of love
I think
it.
we should.
I think we should too.
I just was thinking, we were talking about like different orbits, and you said that the stable one around Earth for lots of moons is a ring of moons. Is it easier to make a ring of these objects than concentric orbits?
No, concentric orbits are always easier. They're more reliable. They're more natural, and so they're much more likely to happen in real life.
Mhm.
It's the orbits that kind of are co-orbitals. You can pack a lot more moons or planets into a given amount of orbital real estate, and so they're efficient for packing things in.
Right.
But in reality, they're probably pretty rare. We know they exist sometimes, so they got to exist out there. Like Saturn's got these moons that are co-orbitals, Janus and Epimetheus, and Jupiter has its Trojan asteroids, and Earth has transient co-orbitals and stuff. But I think those concentric orbits are much more natural and simple to describe.
So do you think we could have more than 11 if we did them concentrically?
Oh, yeah.
So I looked this up too. So someone wrote a paper about this.
This is the maximum number of moons.
between us and our moon, or even further out?
Well, at some point they get the gravity of the rest of the solar system is a problem.
At some point.
So with things the size of our moon, you could fit 3 like around the Earth. For things down to Pluto mass, it was like 4, and down to Ceres mass, they got to 7 or 8.
Oh, all right.
And so that's on concentric orbits, going from the innermost one being at the Roche limit. So any closer, it would get torn apart. And the outermost one being kind of at the stability limit, which is about twice as far out as the moon is from the Earth now.
How far is the Roche limit?
It's about 2.5 Earth radii above the Earth.
Okay.
So it's pretty close.
But it's whipping
close
around
by.
pretty fast at that point.
Yeah.
And you said that would be like anything put there could be stable if it were Pluto sized or Ceres sized?
Oh yeah, as long as it's past the Roche limit, something pretty big should be able to be stable. Yeah.
Now we have a special offer for Dead Planet Society listeners. You can get a 10-week digital subscription for $10 or £10, which includes unlimited access to our website and app. To learn more, go to newscientist.com/DPS offer.
And if you enjoy our podcast, you might also enjoy my free monthly space newsletter at New Scientist, Launchpad. Check it out at newscientist.com/launchpad.
We also have an exciting new event series launching in the U.S. Join us in New York City on June 22nd for a full-day masterclass exploring cutting-edge research on the mind and consciousness. You'll hear 6 talks from leading neuroscientists and philosophers about some of the biggest questions out there. When does consciousness begin? How does our brain create conscious perception? And what role do dreams play in our conscious experience? To learn more, visit newscientist.com/New York Mind.
We're putting 11 plus moons in orbit around Earth. Would that be bad for us? It usually is when we do things like this. It usually messes up Earth.
I think if you did it right, it'd be okay. So like I said, I was playing around with this stuff earlier. There's the rings you can do, rings of Ceres. That's okay. I bet you could fit 2 rings to get like 20 moons in there fine.
But would there be, they would be fine, but would we? Like, what about tides?
Oh yeah, tides would be fine. It wouldn't change tides too much.
Really?
Tides are,
Yeah, whatever.
I wonder if it would increase our Earth's like equatorial bulge.
a little bit. I think tides would be stronger, and it would kind of stretch out the equator, kind of like tides do now, but in a slightly different way because it'd be pulling on all sides at all the time. So I wonder how that would average out.
Yeah, maybe
It'll
we
be
would
interesting.
feel it that much.
Yeah, I mean, it would be pretty in the sky, and it'd be kind of really cool from a certain point of view, but it would also be dangerous because anything goes a little bit wrong. What's going to happen to those moons? They're going to crash into each other. A bunch of debris is going to fall on us and, wipe out a city or two, something like that.
Yeah, the domino effect is bad.
Yeah.
But also, the night sky would be a lot brighter, wouldn't it?
Oh, yeah.
Oh,
Yeah.
astronomers are gonna hate it. Yeah.
So this is never no moon.
Yeah, never no moon. The best place for astronomy would be at the poles, because then you could at least escape.
It seems like at most places, especially around the equator, like a lot of the time you wouldn't be able to see stars because the sky would be so bright.
Yeah, I think you're right. I think so.
That would be, that's a little bit of a bummer. I do like lots of moons, but I also like the stars.
Yeah, it's tough to balance those.
Mm-hmm. Is there a point at which we've packed Earth's general neighborhood so full that it becomes hard to launch things? Depending on where we're going, but are we making our own amount of space junk?
Oh yeah, I mean it would be a considerable amount of space junk. In terms of launching stuff into space, would that be a problem? If you really had all these moons sitting there, it wouldn't be so bad, I don't think.
Could they be little way stops?
Exactly. They still have enough gravity that you don't really want to go land on them, because then you're just throwing away a bunch of energy that you just got from your rocket. But you could easily put little space stations around them to go stop over, use them for slingshots. You might be able to get orbital slingshots off them.
Oh, that'd be
and travel places pretty fast. Yeah, it might be pretty useful overall, actually.
okay.
That's shocking.
Yeah, I love
Yeah.
it. I love it when I find out that we've made something useful.
Yes.
Yeah.
I also, in my head, when we were thinking about how many moons, I wasn't thinking about just doing a planar orbit. It seems like we could get some stuff going on a perpendicular orbit to that too. And then I just wonder if we could put enough up in weird different orbits that we could block out the sun like passenger pigeons.
Block out the sun as much as possible.
I wonder how much of... I know that this is maybe not an answerable question.
How many moons does it take to block out the sun?
But like, I just want to look up and it's just moons.
Just moons.
Just moons.
Nothing else.
All the way down.
That would be a tough one to build. People are always bummed when I get asked this often, like, why do you always put moons like in one plane instead of like a bunch of weird planes? And it turns out you can stick a lot more stuff, basically a lot more orbits close to each other if you stick in one plane. Once they're in many planes and they all excite, basically they change the shapes of the orbits of each other's orbits, they end up getting stretched out. And so sometimes it can be stable. You just have to have a much more widely spaced. And so that's not good for your answer. I'm sorry. But I mean,
but probably good for
it would be
humanity
cool.
that I can't block out the sun with.
Yeah, I think
I mean,
everyone.
it'd be good for climate change if you could block out a little bit of it.
I like this.
So now I'm wondering if we're going to put a bunch of moons and perhaps moons around those moons around Earth. Where do we get the moon stuff?
Oh, to actually do that?
Yeah.
That's a challenge right there. I mean, the best place, the least energy place to get is from asteroids.
Oh, sure.
But if you want to build, if you know, you really want to do this thing and have 10 Ceres-sized things, right? Ceres is a third of the total mass of the asteroid belt in one object. So that means you need something like 3 times the whole asteroid belt around the Earth. So you got to go find it somewhere else. You got to go, you know, to stuff that's orbiting Jupiter.
We start with Earth's moon. Smash.
Oh yeah, I
that
guess
up.
you just.
We're not
I guess we just
smashing up
smashed
our
it.
moon.
You're right. That's the simplest.
We have to get rid of it in order to have 10 moons.
All right, fair. That's fine. What a trade-off.
So we start with Earth's moon, and then we just start excavating parts of Earth and launching them.
Launch parts of Earth.
Because
That'd
it's
be
hard to get an
interesting.
asteroid and bring it all the way here.
Like, do our own Thea.
Yeah.
Like,
Yeah.
just, you know,
Yeah.
instead of waiting for a
Undo.
large body to smash into us, just huck our own stuff out there.
It's me. I'm the
That
problem.
would be awesome if you could do that.
I wonder if, like, when I think about rings, I'm just thinking back to the 11 moons. When I think about rings, like the rings of Saturn, I think of them as being sort of very thin and fragile. And I wonder if we could do the opposite of that and build just a wall, just a solid ring on the whole orbit. Or would it crunch itself together?
So to do that, how would you do that? Basically, if you want a thing to be solid, there's this concept of the space elevator, right?
Uh-huh.
Have you heard of this idea, right?
Mhm.
And so to do that, you have to have something that's long enough and basically strong enough that its center of mass is at the co-rotation radius with Earth at the geocentric orbit, but it stretches all the way down to the surface, you know, close to the surface and all the way out. So you'd have to do basically a whole network of those kind of things and then stick them all together.
Oh, and then just
think
like
that could-
run up material to them?
Yeah, sure.
Yeah.
So build a ring of
I'll take
space
easy.
elevators. Easy peasy. We got that.
Yeah.
And then
Check.
Exactly.
shuttle
Exactly.
up like all of our mountains and build a wall. Yeah.
It could be a tunnel instead of a wall.
A tunnel? What do you mean?
Yeah.
What I'm thinking about is the LHC, but big.
I mean, that would be
Oh, dude,
incredible.
a giant particle accelerator.
Yeah, I mean, I don't know
that'd
that
be
I
pretty interesting.
care about accelerating particles in it that much. I do want to go in it, though.
Well, yeah.
But I also do want to go in the LHC. So
Yeah, that would be cool.
I wonder if it would crunch itself up at some point.
Yeah, if you had that, I think there's the differential rotation that you probably just get torn apart.
Yeah.
Because it'd be
that's
too close,
The most
yeah.
likely thing. That's what happens with the space elevator thing. It's basically, you know, trying to tear itself apart. So that's why it's so hard to build, because you need something that's long enough and actually strong over that whole length.
It's like indestructible. Yeah.
Yeah.
Okay.
And so they've made materials that can do it, but they've never gotten them longer than, I don't know. I looked this up a few years ago. That they had never gotten one longer than 10 centimeters,
Yeah.
something like that. And so you need to go
Just
know,
shy.
100,000 times further, something like that.
Well,
Sure.
now I'm wondering about just the moon idea. If we have, we've got 11 moons, maybe they've got some moons around them. They're all around Earth. And I'm wondering if we can make them useful in a different way. Like, could we outfit them all with solar panels? Could we, sort of harvest energy better? If they're always all around Earth, it seems like they'd catch a lot of sun.
Yeah, Earth's solar panels
Sure.
would be better because they could operate at night.
What do you mean?
Because the sunlight reflecting off all the moons would be so bright
Oh,
that our solar panels might be able to collect a little bit of energy in the
A
nighttime.
little bit.
Yeah.
Yeah, it'd be like the full moon, I guess.
Yeah.
Having them directly on the moon, though, is not a bad idea. Then you could totally use them as giant solar panels if you want.
We're actually doing a humanitarian mitzvah.
Oh, totally. Totally.
I love it.
By breaking up the moon into 11. Once again, I must say, you're welcome. We're fixing the universe one planetary wreck at a time.
Thank you all for joining us for Dead Planet Society. If you want to catch up on previous episodes, head over to newscientist.com/deadplanets. We've got a lot of great things coming up for you this season. Look forward to new episodes every other Tuesday, right here in the New Scientist feed.
And thanks to Kieran, who wrote in with one of the most destructive ideas we've ever heard. He wants to make every star in the sky go supernova all at once.
The Cosmic Fireworks Show. I love it. But yes, I think that is more destructive than anything I've ever considered. Kieran, you're a natural Dead Planeteer.
Welcome. You're a legend. And if anyone else out there has another cosmic object you want us to figure out how to destroy, let us know and it could be featured in a later episode of the podcast. Our email is deadplanets@newscientist.com.
Bye. Bye.